yesterday. Please, who can tell us what they remember from our session yesterday? Dennis.
Yeah, so yesterday we continued with service management on Linux, and we looked at the systemctl command and how to use it to identify services and um, perform various tasks on them. We also looked at package installations and upgrading and updating your shell to the current programs. So yeah, I'll just leave the rest for other people to also share.
All right, thank you, Dennis. Gifty.
Hi, Akosia. Please, yesterday we looked at some conditional statements, some commands that we can use when we want to make conditions like in our programs or in our scripts. So we came across the if, else if, and then the elif command. Yeah, we saw the difference between them, the differences. And then okay, I'll leave the rest for others to also talk about.
Okay, thank you, Gifty. So we looked at bash scripting and the control statements that you can use while bash scripting: if, elif, else. All right, Ruben.
Yeah, good afternoon once again.
Good afternoon, Ruben.
Yeah, I also recall about we were on service management, as our brother rightly said. And I also heard or I learned that we have variables. And with these variables, we have shell variables and environment variables. But first of all, we got to know the definition of shell. That's it accepts and interprets commands. And with that, we got the shell variable to be in lowercase, whilst the environment variable should be in the uppercase. Thank you.
All right, Ruben. Thank you too. Okay, who else? Joshua, Mina. Emmanuel Odum.
Yeah, hello, Akosia. Good afternoon.
Good afternoon.
Yeah. Please, yesterday we talked about logging as well, where we talk about one common command, last log, to check the last time the users on that system had logged on. And also we talk about a similar service by AWS called CloudTrail, which is also used for logging. So that's what I can say briefly about logging.
All right, thank you for that, Emmanuel. We spoke about how there are system logs, there are logs from using the package manager, the apt. There would be individual logs from the various applications or the various services used on your server. And when we talk about logs, we are just talking about records of events and everything that is happening inside your system. Okay, thank you, Ima. So today we are beginning with networking. Share my screen. Okay. So what do we understand by networking? When you hear the word network, what comes to your mind? I remember on the introductions day, a lot of us were using the word networking as one of the reasons or the goals that we hope to get from this training session. Eugene Amweni Afo.
So network can be two or more computers or devices that are linked together to share resources or information.
Right, thank you, Eugene. Ruben.
Yeah, in simple terms, networking is connection. So connecting from one point to another.
All
So
right.
in relation to computers, that means connection of more computers.
Okay. Thank you, Ruben.
Welcome.
Asari Daniel.
Yeah, good afternoon.
Good afternoon.
Okay, so please, in respect to building like friends, networking, like you said, most of us, the ambition was to network with people. So in respect to that, it's more of like building a relationship with someone, and also nurturing a relationship. So yeah, that kind of stuff. So
All
like
right.
building a relationship with someone. Yeah.
All right. Thank you, Daniel. So when we speak about networking, we just mean individuals or various computers, in this case, being able to communicate, being able to transmit data, being able to transmit information between themselves. So various devices being able to share and transmit data. That is what we mean when we talk about networking. All right, so what do we understand by the internet? When we say the internet, Dennis.
So the internet is like a wild or wide interconnection of devices to share resources. Yeah.
Thank you. So the internet is a large network where devices are able to share resources. Devices are able to transmit some data between them. Gifty.
Yeah, so the internet is like a worldwide interconnection of devices, like they are cooperating together, exchanging information, like yeah, and working on a common standard. Forms an internet.
All right, Gifty. Thank you. Daniel.
Yeah, so like in my own, perspective, like first of all, inter means a connection of something. Inter means connection, and net means network. So like as my brother explained earlier, that networking, I mean, it's a connection of two or more computers. So when you bring it together, it's more of like a connection of, I mean, network devices, which are, I mean, which are coming together. So that's my
All
perspective.
right. Thank you, Daniel.
Thank you.
So with how the internet started, the aim was for an agency to be able to send a message between themselves and a partner university. So for example, the Amalitech office, for instance, is in East Legon, and we are working on a collaboration with Legon, for instance, and the idea started from how we would be able to send some data to the school, to Legon, for example. So that was how the transmission control protocol and internet protocol were developed, because we realized that in order for that to happen, we would need to find a way to link their network and then our network together. And from there, the idea revolutionized to having a network that served just the local area, so a particular geographical area. That was also made possible. And then much later, the HTML and then the URLs, which were created, so the World Wide Web, which we also refer to now as the internet, was also created. So being able to locate certain pages or certain sites, being able to come across their HTML pages with the help of the Uniform Resource Locator. And since then, it has just kept getting better. And the devices that we use today, our phones, our laptops, they all make use of this interconnected networks. So when we talk about computer networking, it's just the connection or the networking, or the connection of computers. So computers being at various different geographic locations or being at various places are able to transmit data or are able to send some information or share some information between each other, even though they are not in the from being able to connect to one network. So from being on the same network, they are able to transmit data between each other. So for example, the client, so me and the office as the clients, and then somebody else, with the first example that I gave, somebody else in Legon, for example, being able to get my data transmitted from where I am to where the person is. So that's transportation being able to work out due to the help of a network. So it's just data transmission from point A to point B, and the devices need to be logically connected inside the network, inside what is making the connection possible. And when we speak about computer networking, at the center of it, or the key players inside that network are the nodes. The nodes are the various devices or the various computers that we use to access the network. And any device that we use, that we can connect to the network to make data transmission possible is referred to as the node. And then the host is like an optimized node. So the host too kind of is a node, but what the host is the host has more capabilities than just the regular nodes. So I've mentioned how you can optimize or configure your device to be able to share data. So for instance, a node will just need to access data, but what a host does is the host is what actually has that data to give, for instance, in this case. So the nodes connect to the host so that the nodes can access whatever data or whatever services that the host has to offer or has to serve. So with our EC2 server, for instance, if I should give my the address to our server, the public IP address to our server, and I use my phone to access that address, I have been able to make a connection to our server, and I would probably be using it to get some content on our web server. Okay, so I have been able to network from my phone here in Ghana to the host, which in this case is the server that we provisioned inside US East 1. So thanks to networking, I will be able to use this node I have to access that host. So a basic computer network would have a switch, it would have the host, the node. These are the clients or the node, and then this is the server, and then this is the switch, which takes care of the data transmission between the sender and then the receiver. So the switch is what makes sure that if computer A is sending something, it will be able to distinguish between between who the target or who the receiver is for, and then it goes ahead and then it sends to whichever receiver that's computer A intended the traffic for or intended that data for. So that's what the switch does. And when we're looking at the components of our computers, we mentioned the RAM, the ROM, and one of the components is the network interface card. And that is present in each node. So for your computer has a network interface card, and this network interface card is the point which your computer uses to connect to a network. So it works directly or hand in hand with the switch. So the switch knows, okay, so this traffic or this data came from this node's interface card and is destined or the target for it is this other computer's network interface card. So these are some of the elements of a computer network, and we'll be looking at them into more detail. So if you have just a few computers, the switch would be enough to be able to cater to it. But when it has to extend. So if you want to connect a number of computers to another number of computers, then you would need to connect your two switches using a router. And one of the components that come inside networking too, apart from the node and the network interface card, is also network cables. They are also used to establish the connection and make the networking capabilities possible. And they are connected from the node to the switch, and then sometimes from the switch to the router in cases that require the router. All right, so data and the OSI model. Who has heard about the OSI model? Or who can tell us something they know about the OSI model? Jesse.
Open system interactive model is for the when data is transferred from one network computer say need to data for
Please,
data.
your line is not clear. Please come again.
Yeah, hello, can you hear me?
Yes, I can hear you.
So I'm saying that the open system is a form of a layer that
Okay.
when data is being transferred from one network that it goes through series of processes for the data to be transferred to yeah network for the node is being typed.
Jesse, your network is really bad. It keeps breaking.
Is it okay now?
Yeah, speak again.
Yeah.
No, it's still happening.
You have tested with just
If you could put in the chat, that would help. Penty.
So the OSI model is a sequential order. It's a defined sequential order by which information is exchanged from, or data is exchanged from one end to the other.
All right, thank you, Penty. Daniel.
Yeah, the OSI model, like Betty said, it's an order whereby information is being shared among network computers. So what I know also is that they have 7 stages where the information are being shared. So I'm here to learn more.
All right, thank you, Daniel. Eugene.
Yeah, so just to add something little to it, I think the OSI model also the layers, just like Penty said, it's got them in software and hardware layers, and then in the heart of it is the transport layer. I'm sure we probably might talk about it. The transport layer that connects the software layers to the hardware layer.
All right, thank you, Eugene. So when we speak about OSI model, it's a way or a standardized way of communication for data transmission. So the data that we are talking about that gets transmitted over the network, there was the need to give a standardized way. So a standard way or the required way for that data for that data to get transmitted, especially considering that there were multi-vendors for the various networking systems. So these vendors, what are the layers or what are the components or the requirements that they have to have inside of their networks for data transmission to go on smoothly. So that's what the OSI model stands for, or that's the essence of the OSI model. And when we talk about data being transmitted over the internet that we're talking about, for instance, is in bits and bytes, and they equal the value of 0 or 1. So the media that we see, the numbers, the text, all the data or all the information that we transmit over the internet, they can be or they are processed inside the computer or inside the network as bits and bytes. It could be pictures, documents, code, text, etc. And they are able to be transmitted over the network and saved as the various destinations. So the OSI model defines a standard for how computers should share information or should transmit data over a network. And it's made up of 7 layers, and each layer has an aspect or has a function that they perform when it comes to the different aspects that the data has to go through to successfully get transmitted. So in an OSI compliance network, from the source computer, so the sender, and then this is the receiver. So the source computer has the data go through these 7 layers, and then the target computer also receives the data and has it go through the 7 layers to be able to have that data or have it processed. All right, so there's a video I want us to watch. It summarizes the essence of each layer and what each layer does when it comes to data transmission. So let me just get that set up. I would also drop the link in what's it called? I'll drop the link in Slack for anyone who wants to rewatch. Okay. Then I will share.
Newsletter. Please subscribe.
And it's only here.
Yes, you can.
Okay.
How is data sent over the internet? What does that have to do with the OSI model? How does TCP/IP fit into this? Let's take a look. The OSI model, or the Open Systems Interconnect model, is a theoretical framework that provides one way of thinking about networking. It splits the network communication between two devices on a network into 7 abstraction layers. The physical layer is the bottommost layer. It is responsible for transmitting raw bits of data across a physical connection. The data link layer is the second layer. It takes the raw bits from the physical layer and organizes them into frames. It ensures that the frames are delivered to the correct destination. The Ethernet primarily lives in this layer. The network layer is the third layer. It is responsible for routing data frames across different networks. The IP part of TCP/IP is a well-known example of this layer. The transport layer is the fourth layer. It handles end-to-end communication between two nodes. This is the layer where TCP and UDP live. TCP provides reliable end-to-end communication between devices. It does this by dividing the data into small, manageable segments and sending each segment individually. Each segment has a sequence number attached to it. The receiving end uses the sequence numbers to reassemble the data in the correct order. TCP also provides error checking to make sure that the data was not corrupted during transmission. UDP is another popular protocol in the transport layer. It is similar to TCP, but it is simpler and faster. Unlike TCP, UDP does not provide the same level of error checking or reliability. It simply sends packets of data from one device to another. The receiving end is responsible for determining whether the packets were received correctly. If an error is detected, the receiving end simply discards the packet. The remaining layers are session, presentation, and application layers. This is where the OSI model loses its usefulness in practice. They are too fine-grained and do not really reflect reality. In general, it is sufficient to collapse them into a single layer and consider application protocols like HTTP as simply layer 7 protocols. Now let's go through an example and examine how data moves through the layers when transmitting over the network. When a user sends an HTTP request to a web server over the network, the HTTP header is added to the data at the application layer. Then, a TCP header is added to the data. It is encapsulated into TCP segments at the transport layer. The header contains the source port, destination port, and sequence number. The segments are then encapsulated with an IP header at the network layer. The IP header contains the source and destination IP addresses. A MAC header is added to the data link layer with the source and destination MAC addresses. It is worth noting that in the real world, this is a bit nuanced. The MAC addresses are usually not the MAC address of the sending and the receiving ends. They're the MAC addresses of the routing devices in the next hop of a usually long journey across the internet. The encapsulated frames are sent over the network in raw bits in the physical layer. When the web server receives the raw bits from the network, it reverses the process. The headers are removed layer by layer, and eventually the web server processes the HTTP request. To conclude, the OSI model is one way of thinking about networks. Its primary purpose is educational. Even though the layers don't fit the real-world use cases perfectly, they are still widely used by networking vendors and cloud providers as a shorthand to describe where the networking products sit in the OSI model. For example, cloud load balancers are broadly divided into two categories, L4 and L7. An L7 load balancer is a shorthand to mean that the load balancer operates at the application protocol layer like HTTP or HTTPS. An L4 load balancer, on the other hand, operates at the TCP level. If you would like to learn more about system design,
All right, so that was a summary on what each layer does and a demonstration on how our traffic or our data gets sent across the network when it comes to the OSI model. Give me 2 minutes. I would share my screen back again and then we continue. Okay, so it spoke on the fiscal to the transport layer, but the session and presentation layer, we'll just touch on that if you. So the session layer is what takes care of it starts and terminates sessions. So from when you start to use the network or when you hop on the network to get your data transmitted or to get some tasks accomplished, the session layer is what's responsible for starting that session. And when you're done, terminating the session. And the presentation layer is what makes sure that whatever data you are transmitting is in the correct format and it would be able to get transmitted. So zeros and ones. So with the way we see letters, maybe our A and our B and all those things, the computer sees those that data as something else. And I think this is the name for it. So the way that data is encoded for transmission. So if it's A that you are sending across, the system sees it to have like a binary value of zeros and ones. So that's what the presentation layer is responsible for. It's responsible for making sure that whatever data you are sending is in the right format. So you would send it, or you would present it in the human way, and then it is responsible for making sure that it is in a format that the network is able to understand and work with and transmit. So that's what the presentation layer 2 does. And the application layer is where the users directly interact with various applications. So it's at the application layer that I would meet this web page. So for example, me visiting this web page, I am I'm making use of the application data. What layer, whatever use or whatever I want transmitted, it is here, or the application layer, that the user is going to interface with. Yeah, so this summarizes everything too. This the session layer maintains the connection from when you start to use the application till till you need to terminate that connection. The transport layer is what's responsible for sending across that data, and the network layer is the path that that data would take to get transported. And the data link layer defines the format of the data on the network. So at the data link layer, whatever you're sending is saved or is stored as a frame. It's called a frame, and it's includes whatever message or whatever data that you want transmitted. It's stored as a frame and then sent across. And the physical layer has to do with the physical components that we need to be able to network. So the switches, the cables, etc. So they are at the physical layer. So after the data has been transmitted and then the target node or the target computer receives the package, it also unpacks the data through the same OSI model, going through the 7 layers, but in the reverse order. So they would go from physical through to application. So that's the receiving node. After it receives it, it goes through this order, and then when it gets to the application, the receiver is able to access whatever data it is through whatever application that they expected the traffic on. So the message or data at layer 2 is called a frame, and frames are associated with a MAC address. So the MAC address, each network interface card has a MAC address. So your computer's network interface card has a MAC address, and this MAC address is like a physical ID. And at layer 2, it helps for the node to, it helps to identify the node that is going to receive or send whatever traffic or whatever data it is. So that is what the MAC address does. We'll get into more details about it shortly. And then the network layer is what holds information such as the IP addresses of the various nodes on the network. So that happens at layer 3, and this information is stored as packets. They're called packets, and they contain the message or data. And the IP addresses also help for the network to identify which targets that whatever data is going to. So the components of a network, we'll be looking at client, server, the network interface card, network cables, switch, and router. So I mentioned that each computer has a network interface card in it, and when it's being manufactured, when the computer is being manufactured, this network interface card is assigned a MAC address. And this is the router, which we would use to connect multiple switches, and we can have the switch connecting the various network interface cards of the nodes. So when we talk about a client is a hardware device which allows the user to access the network. So your phones, your laptops, your computers, they are all clients because they're helping you to access the network. So for example, if I should send an HTTP request, or I should request for some data from Amazon servers, in this case, if I use my computer, for example, then in this case, my computer is the client who is trying to connect to the server. And the client accesses data or service that is managed by another node or another client. So I mentioned how the server in AWS, for instance, is we borrowing a server from, or we borrowing a computer from AWS, for instance. So in that case, the server that we have provisioned, since it is not just a client, but in this case, it does more. So it's the server that has whatever information that we are trying to access. So we, using our personal computers, are the client, and then the server that has whatever service or has whatever data that we are looking for. Probably we are trying to get to a web page which the server is serving. Okay, so in that case, the server is in this case, we are the clients, and then the server is what is managing whatever data or service that the client is trying to access. And a client can also be the software that you use to access the server. So when we were accessing our server, for instance, we might use a browser, for instance. So in this case, our browser is the client, because that's what helps us to be able to access whatever web page or whatever service that we need from the server. And the server is what's going to give us a response and serve us with whatever it is that we are looking for. So with this example, the client accessed the server that is hosting the Amazon.com, and then this server sends back a response, which could be an order number or just something for the client to know that, okay, whatever they tried to request for, whatever data they were trying to retrieve, or whatever thing they were trying to get done, it has worked. So the server's job is to respond to the request from the client. And examples of servers are web servers, database servers, file, mail, endpoint service. So we could also access a database server where we would have it give us some information that we are looking for. So in that case, yesterday we downloaded Nginx. I mentioned that Nginx would help us make our EC2 server a web server. So another service like my SQL can also help to, it's also a service that you can use to make your server a database server. And when you put other configurations in place, you would be able to query data or retrieve information, retrieve and store and manage information or data that would typically be found inside of a database. So usually the web servers and database servers usually work hand in hand. The web server is serving and even collecting data and content, and then is storing inside the database server. So the network interface card, that is the component inside all of us our computers that helps us to be able to connect to networks. It could also be called the network adapter. And it uses a cable that is connected to a hub or a switch. So those of us who know about Ethernet cables, when you, like in this image, for instance, when you want to use wired internet service or cabled internet service, you would use the cable to connect to your machine, and then this connects to your network interface card, affording you to be able to get the internet access. And each network interface card has its MAC address, and the MAC address is assigned by the manufacturer, and it's unique. No two computers have the same MAC address, so the manufacturers have made sure of that. That way, when the data is being transmitted, or when the switch is deciding who the target is, or which targets the data should go to and those things, it will know that, okay, this is the only, or this is the destination, and that destination for that MAC address is unique. So there's no way data meant for a different computer or a different network interface card would end up at another network's destination as its destination. So network cables are also used to physically connect networks together. We have the fiber optic cable, which is the most common today because it's the fastest. And then we have the coaxial cable, which was, well, it was the most common then before fiber optic took over. So, but it's still being used in some places to connect TV modems to the internet service provider. And then the twisted pair is also what we will find, those of us with telephones in the house. This is the cable that we would usually find being used. And the Ethernet cable too is also an example of the twisted pair. And the twisted pair could be shielded or unshielded. Okay. So the switch connects the various nodes to the network. So the various nodes of a network, they come together and then are connected, or to connect them together, you could use a switch. So the switch transmits data to the receiving device using the MAC address. As I mentioned, the MAC addresses of the various computers they are unique, so they'll definitely be different. So at the data link layer, the switch knows to send the data to this MAC address or this MAC address. And the router is a way to connect multiple switches. So when we look at this, for instance, we see that these 3 nodes are connected to a switch. These 3 nodes are also connected to a switch. And then the router connects those 2 switches. So right now, these 6 nodes are all part of the router's network. And then the router is able to send and receive data between these 6 nodes. And the difference between the switch and the router is that the router is able to filter traffic or filter the data coming in. So by IP address, by protocol, you are able to get the router to perform filtering or sorting out activities, okay? But the switch does not have that capability. And the router operates at both the data link layer and then the network layer of the OSI model. And a modem connects your home to the internet. It would usually have 2 ports and one connecting to your machine and then the other connecting to the outside internet. So dependent on the modem that you have, you could be using a wired connection to your ISP with the use of the Ethernet cable, or you could also use the wireless internet connection. In this case, you would be using the router. So typically you find the coaxial cable when using the modem to connect your home or the devices in your home to the ISP, to the internet service provider. But those of us who have experienced using the modem and then using the coaxial cable with our modems and then using the fiber optic cables with our routers, we realized that the fiber optic cables truly are faster as compared to the coaxial cables that are used with the modems. Okay, so what can a router do that a switch cannot? I mentioned that the switch being able to send the data over and knowing which MAC address or which device to send the data to. So I mentioned that the switch does for when you have a smaller number of nodes, and then the router is for when you want to connect multiple switches. So like the router is like an optimized switch. So it just does a better job than the switch. So you connect various switches to the router. So the router helps you to be able to connect more nodes as compared to the switch. So what is the other thing I mentioned that the router can do, which the switch cannot?
Hello.
Hi.
Hi. This is Beatrice. So you said the router can do filtering, but then the switch cannot.
Thank you, Beatrice. So the router is able to filter through your traffic. It could filter with the IP addresses, it could filter with the protocol. So you can configure your router in a way that if this is the kind of traffic that is coming in, then the target should be this MAC address. Okay, so you can configure your router to filter and then handle the data and the transmission that way, but the switch does not have that capability. Thank you, Beatrice. Terry, you want to add something?
Yes, I want to add that a switch connects multiple devices to create a network. However, a router connects multiple switches.
Thank you for that, Terry. Dennis.
Yeah, I also wanted to add that the switches are not capable of connecting the devices to the internet. It's the router that connects to the ISP. Then the ISP connects to the global internet. So the switch is on the node level, while the router is able to network with the ISP and then connect whichever switches are connected to itself to the global internet.
All right, Dennis, thank you. What does the network interface card use that is known as a unique identifier given by the manufacturer? Question 2. Calvin.
The MAC address.
The MAC address.
Thank you. The media access control address, MAC address. Okay. So please, are there any questions before we move to networking concepts? Okay. So let's look at some concepts when it comes to networking. We're going to be looking at the types of networks, the common network topologies. When we say topologies, it's the design and the network management models, how we manage our networks, and the different types of network protocols. Okay, so the first type of computer network we would look at is the local area network, and this typically just spans a smaller geographical area, for example, the floor of the office or a whole building or just a campus. So that smaller geographical area it would typically use the local area network, which is the LAN. And then there's also the wide area networks and that one spans a bigger geographical area such as cities or even the whole country. So that would be for the wide area network. And then the local area network has to do with a smaller geographical area. So the local area network is limited. So the router connecting to the ISP, for example, and then connecting to the switches. So the switches are going to be hosting the nodes. So the nodes or the hosts are connected to the switch, and then the switch is then connected to a router. And because it's the wired network is able to afford the high data transfer rates because of the use of the Ethernet standard. Could also use wireless technology for local area networks. So the wide area network, they connect devices in a large geographical areas such as multiple cities or multiple countries. So with the way an area like Legon or a campus like Legon would have their local area network, and then a place like, for example, if Legon would also have their local area network, you can use the wide area network to connect these individual local area networks. So we can see that from the image here, that there's one router that's connecting the router of the LAN of one geographic area, and then of another geographic area, making the geographic area that this network is covering a larger one. That's making it more of a wide area network. So a good example would be having two corporate offices. So for example, you work for a company that has they have their office. So there's one in Chowlu, and then there's one in Adenta, for instance. So connecting the local area network in Adenta and then connecting the local area network in Chowlu would could afford them having a wide area network. And the internet is considered to be the largest wide area network. So this image compares the local area network to the wide area network. So for example, this is the Ajawulu branch, and the departments A, the 3 servers or the 3 computers in departments A and B connecting to make a local area network. And then this is when they connect the various branches. So this is Ajawulu, this is I mentioned Adenta, and then they would now be, the network type will now be a wide area network type because it's connecting to local area networks. So what connects them is the wide area network. So what connects these two local area networks is the wide area network. So when we talk about topology, it's just the pattern or the way that the nodes are connecting to each other. And based on the way they are connected, or based on the design of how the nodes are connected, the computer networks would also use that design or that pattern to share information. So the way you design your network, the way the various nodes are being placed or are being configured inside your network matters, because that is how the information or whatever data is going to be transmitted to them or is going to be received and sent between them. So the physical topology has got to do with the wiring of the network, and then the logical topology refers to how the data moves through the network. So these are some examples of the kind of design you can have when it comes to placing the various nodes inside your network. We would take a look at them one after the other. So each of the nodes inside your network have a role to play, and then dependent on how they are connected or the relationship they have with other nodes in your network, that is how data is going to flow within the network. So when we talk about the physical, it's just the design. So where this one is placed, where that one is placed. So the bus topology, for instance, all the nodes are positioned along a single cable. So this node is here, this node is here, this node is here, but they are all along this single cable. And the star topology has to do with when the nodes are centralized around the switch. So dependent on your networking needs, you would pick one topology over another. And the hybrid topology has to do with when you use more than one of the network topologies that are available. So when you make use of more than one, then you're going with a hybrid topology. And one common hybrid topology is when the star and then the bus topologies are used together. And the bus topology could also be called line or backbone topology. It's simple to configure, but it only allows for one computer to send a signal at a time, because all of these nodes make use of this single wire. So it only allows for one client or one node to send a signal at a time. And the star topology is set up in a way that every node directly connects to the central switch. So that is a better design as compared to this, because the switch is centralized around them, so they would all be able to make use of the individual coaxial cables that connect them. So with the mesh topology, they are interconnected. Could be partial mesh or fully mesh. An image of the mesh. Okay. Image of the mesh wasn't provided. Let me just put that on. Okay. So this could be an example of the mesh topology where they are all connected. So all the nodes are interconnected. So each device is connected to at least two other devices, but in a full mesh topology, all of the devices are connected to each other. So there's wiring from each node to another. And since it requires each node to have multiple network adapters and cables, it is the most expensive of the topologies that we are looking at. So when we talk about hybrid, it's combining two or more different topology structures, and it's usually found in large organizations. So we've looked at the physical topologies about how the wiring connects the various nodes, and we are moving on to the logical topologies, which refers to how the data moves to the network. Amazon VPC is an example of a logical topology. So what VPC does is it gives you your isolated network in the cloud. So you are able to launch your resources inside the VPC that you define. So it's virtual private cloud. So yes, it's AWS's cloud, but inside it, but the VPC is kind of yours. So it's your private cloud. And it works just like a normal network within a data center. And you get the full benefits of using the AWS services, and you're able to scale your resources as you need. So the physical topologies that we've looked at also have an impact on how the data moves through your network. So with the bus topology, for instance, it also moves, the data moves in one direction. Get the image. Okay, let me go back to the images. So in this case, if this node is transmitting data, it would go this way. So this client or this other node would be able to receive data. So they're going to be receiving the data at different times because the data is being transmitted in one direction. And then with the star topology, for instance, the data would be able to get transmitted faster because it's being transmitted all directions. Okay, so we're talking about. And then the mesh 2 is also like an improved version of the star topology. So that would also enhance data transmission. So the VPC, AWS VPC, is a virtual network that allows you to launch your resources inside your private cloud. And it's more of a logical network, considering that we do not take care of we do not configure or influence the wiring. So with VPC, it's more of a logical topology. So we have control over the logical topology of things than the physical topology. All right, so when it comes to Amazon VPC, it allows you to launch your resources inside a private cloud. And so we are looking at some similarities between AWS services and then the traditional network topologies. So in a traditional network topology, you might have an isolated network. So even though it is the network for the company, you might have an isolated network for probably various tasks. So maybe for various departments or anything like that. No, let me take that again. So comparing the traditional topology to AWS, for an isolated network, for instance, your company. So for example, in Amalitech, we have our isolated network. We might be making use of resources from an ISP or something, but we would still have our isolated network. So it is on our network that our nodes or our computers connect. And that is the same idea too in Amazon VPC. You're making use of AWS's resources, but then the VPC affords you the ability to have your private cloud. And when it comes to network segments, for a company, for instance, even though they have the isolated network, they might want to further divide into various smaller networks for different purposes. So it could be that there are different departments or there are different, even though it's the same organization, there are like different departments or different groups under the organization. And that is where the need to segment or to divide your network would come in. So in the traditional topology, that is also, that is a thing in the traditional topology, but in AWS too, there is a similar concept, which is known as subnetting. You would be able to divide your network or your VPC into smaller networks, and then we call these subnets. So when we're talking about subnets, it's just your VPC, and you have divided your VPC into smaller or into more divisions or into more segments. And when we talk about firewall, we mean what protects or what shields the network. So before an outsider or before another network or another user tries to get access to your network, what is shielding or what is protecting the network? So in the traditional topology, we have softwares like the firewall softwares. Guys, please, who remembers? Do we know of any firewall softwares protecting the traditional networks?
Windows Firewall.
Okay, thank you. I was going to say Sophos, but I'm not so sure about that. But then in a traditional setting, we have shields, or we have systems that protect our network from outsiders or from hackers and then people trying to infiltrate. So that's the same idea behind the AWS side too. So for AWS, we have security groups and we have network access control lists. So when we were creating our EC2 instances in week 1, we looked at security groups. Who remembers the ports that we had to go and edit under our security group list? There was a port that we had to open before we could SSH into our EC2 instance. John Albert.
Port 22.
Yes, thank you for that. So because we wanted to be able to send traffic, or wanted to be able to access our server through that port. We had to edit our security group to open that port. And then if we remember, we specified where we would be expecting that traffic from. So AWS2 also has that capability where you are able to edit the sections in your wall or the door protecting your network. So you're able to say which part of the network should be opened and who it should be open to. And so we specified where we would expect traffic from, and we also specified the kind of traffic that we should be expecting. So that's what we did. We edited our security group rules last week. And then the network access control list has to do with your VPC. So the NACLs protect your VPC, and then typically the security groups would protect your instance. So that's as protecting. So if we have the NACLs configured around our VPC, and then we also have our security groups configured correctly around our instances, you understand that for anybody to infiltrate, they're going to have to be able to get past those two barriers before they are able to get to whatever resource or whatever network it is. And then the server too in a traditional, offices, for instance, or inside the traditional topology would be our on-prem server that we've been talking about. And then in AWS is going to be the EC2 instance. Let me see if I can. I want to do a drawing on command. Yeah, I think I will just annotate. So for example, if we someone should visit the traditional data center, for instance, they would find your server. So this is your server, for instance, and there would be a firewall protecting the server. So, and the whole network. So the server is definitely within the network. So let's have this represent our whole network. And inside of AWS to protect your, so this, let's say this is our network. So let me just put in here. So in AWS to protect your network, then you put a NACL around your VPC. So for example, in traditional setting, this your isolated network in AWS, that is your VPC. And then this network, you can further divide it. Okay, so this just further divide it this way. Let's say we divide it in 3. So when you look at your environment, you see that your EC2 instance or your server is in one of these networks. So for example, I've divided my VPC in 3. My EC2 instance would definitely need to be provisioned somewhere inside the network. So let's just say it's in the second one, which is like the middle. So we have this security group or firewall, just put F. We have this firewall guarding the subnets. Okay, sorry, we have the firewall guarding the server or our EC2 instance. So that's also the same idea in AWS. Inside your office building, you have your server. You would definitely have a resource inside your system that is a firewall safeguarding your server. And then inside that, and all of those would be inside your network segment or your network section, which is also inside your whole VPC. Okay. So those are the similarities between our traditional network setting and our AWS cloud. So as I said, every EC2 instance belongs inside a subnet. And then the firewalls block traffic based on a set of rules. So you can ask the firewall to block any traffic that is probably coming from, we'll do IP addressing soon. So you can block any traffic that has this IP address or has some features of this IP address. You can block any traffic that is coming from this port, that is coming through this port, that is coming over this protocol. So you are able to use firewalls to do those things in your traditional setting. In AWS, you would use security groups and network access control lists. And with security groups, by default, they are all the ports are closed. So you would have to go and open the ports, like how we had to open ports 22 last week. And within our data centers, there are servers. So we spoke about how servers are just like EC2. So when we go to borrow EC2 instances from AWS, that's in the traditional setting, it would require us going to purchase or provision a server physically. So this time we are using the server, just that we're using it just that the server is not with us physically, it's somewhere else, and then we are just borrowing it. So we are just using the capabilities of it, but we do not have the server physically with us. So comparing local area network, wide area network, and the Amazon VPC. So we've looked at all three. So can anyone mention or can anyone draw any parallels or any differences between these three so far with what we've looked at? Any similarities and differences we've seen so far? Okay, let me mention names. Osman.
Hello, madam.
We spoke about,
Hello.
yeah, can you hear me?
I can hear you, ma'am.
Okay, so can you tell us any similarities between LAN 1 and Amazon VPC?
Yes, they're almost the same as we were explaining. So the Amazon VPC, you can use it as a LAN by dividing them into networks, and you assign IP addresses to them as subnets, as we were explaining.
Okay. All right, so this picture compares the LAN topology to the Amazon VPC. So some of the similarities we can see is that the instances. So inside a local area network, we would have computers, servers, nodes. Okay, so for nodes, inside the local area network, it's servers and computers, but then inside the Amazon VPC, our nodes would typically be our instances. So the equivalent of a switch inside the local area network would also be the public and private subnets, because the public and private subnets have a way to group all the nodes inside. So if I provision any instance inside this public subnet, the public subnet serves as a switch because all the instances inside the subnets are connected to that switch. Okay, so they are connected to that public subnet. If they're also inside the private subnet, all of them are going to share whatever networking capabilities that the private subnet to has. So comparing them, it's the subnets kind of do the job of a switch when it comes to the local area network. And at the top of it, where there is a router inside the AWS VPC, there's an internet gateway. There's a route table. So this is the route table, and it helps to route traffic or transmit whatever data. So it takes note of the destination and then the target. So if traffic is destined for the internet, so for example, your instance is trying to transmit some data or is trying to retrieve some data from the internet, this route table knows that it needs to route that traffic to the internet gateway, because it's the internet gateway that is responsible for internet access inside the VPC. And if the instance is sending a traffic to a destination IP address, so you can, inside the route table, you can specify destinations. So if it's sending traffic to this destination, then it should route that traffic locally. So just like how the router routes the traffic, and it also helps with the data transmission, that's the same idea that the route table does. And then the route table makes use of resources such as the internet gateway, the NAS gateway, etc., to be able to route those, or to be able to route whatever traffic that is coming in or going out. So you would configure your route table, setting it with a destination and a target. So if the traffic is destined for here, then send it to this target. If the traffic is destined for here, then send it to this target. And then comparing the wide area network to AWS VPC. There's a concept that we call VPC peering, where you make your isolated net, so our isolated network or our private cloud, we make configurations so that our private cloud can communicate with another private cloud. So in that example, you would be using, it's called VPC peering. So in that example, that represents the wide area network in AWS, because I mentioned how the availability zones are within a region. So with this local area network, we notice that it is one VPC. So we can see that it is one region. So inside that same region, this is availability zone 1, availability zone 2. So that's geographic region. Both these subnets are inside that geographic region. But when we come to this example, it's different regions. So the North Virginia region and then the Oregon region. So this extends your infrastructure or your environment to cover a larger geographic area. So this is more of the wide area network, because these regions are quite apart. So in this case, inside the AWS cloud, for example, you would use a or you would make use of a feature called VPC peering. So having your private cloud being able to communicate with another private cloud, usually in another region. So for these two private clouds to communicate and share resources together, you'd have to establish a connection, and you can establish that connection by using VPC peering. And you are able to have them communicate privately. Network management models. Okay, what do we understand by network management? When we talk about network management, Dennis.
Basically, the management of networks.
Okay, so the way there's someone else saying something.
No, I just said smart case.
So the way that we manage our data and the applications that are hosted inside our networks, okay. And then the two most common models for local area network are client server and peer-to-peer. So when we talk about the client server model, the application hosting is centralized around the server, and the clients are distributed around the server. So whatever files or whatever data that the clients need to access, they are all stored on the server or the computer that is serving the content, and then the clients are able to access them. And the downside is that if the server goes down, the clients cannot access the network until the server is restored, because the whole essence of the clients relies on the server. And then examples include file server and desktop clients, print server and desktop clients. So for example, the people I sit with on my floor, my colleagues, we are all connected to one printer. So we are on the printers network, for example. If the printer should go down, we cannot perform, or we cannot send any data or any traffic to that printer. So even though the clients or our computers are okay, the printer being the center of that network, we will not be able to send traffic over it. With the peer-to-peer model, each node has its own data and applications that is responsible for its own management and security. So the nodes or the systems on the network do not have a need for a central server, so they are able to manage their security, their data, their applications by themselves, because all the resources they need to be able to do that could be found within the nodes. So within themselves, they would be able to handle whatever data or whatever applications that they need. The users are responsible for backing up each node, and the security requirements are not restrictive, in the sense that when, as compared to the server ones, the nodes need to access the information or the data from the server on the server's terms on the server's protocols and security requirements, but in this case, the peer themselves manage, or the node itself manages their security requirements. So, and a limited number of peers are used. Okay, let's look at network protocols. They define rules for formatting and transmitting data between devices on a network, and they typically operate on the network and the transport layers of the OSI model. They could be connection-oriented or connectionless. So an example of a connection-oriented protocol is a phone call. So from when the call is made up until when the call ends, both the caller and then the receiver need to stay on the connection for any type of communication to happen. So that is a connection-oriented protocol. And then an example of a connectionless oriented protocol is when you send a package. So for example, you even send a mail. We usually send mails. So for example, you send a mail. Once you have sent that mail, it's just your hope that the receiver receives the mail. We do not need to make sure that probably the receiver is online or the receiver is behind their PC or something before our mail will send. We are just able to send that mail without establishing the connection. So connection-oriented protocol, it establishes a connection, waits for a response, and it creates a session. It uses synchronous communication. That is communication in real time. It's happening at the same time as the sender or the caller is speaking. The receiver is also receiving that data, or is also receiving that data in real time. So that's connection oriented. And with connectionless, for example, that happens asynchronously. So the sending of the data has to go, and then the receiver receives it after. So when we talk about asynchronous, it's just one after the other. So after this happens, and then the other one also follows. And it does not require a session, or it does not require that there need to be a connection while whatever sending is going on. And that would typically require less efforts as compared to the connection one. Because imagine you need to be behind your machine before you're able to receive a mail or a message that was sent. That would be time wasting. So imagine you need to have both sender and receiver active at the time for any form of communication to happen. That is takes more efforts than just sending, and then whenever or if ever the receiver receives them, then he or she does. So this is also the faster protocol as compared to the connection-based one. So it just sends the data, and whether the receiver gets it or it ends up lost or anything, the sender doesn't have any control or doesn't have any insights into that. So examples of network protocols, we have the Internet Protocol, which establishes the rules for transmitting data over the internet. We have the Transmission Control Protocol, TCP. It provides reliable, connection-oriented, ordered delivery of data over an IP network. And the TCP IP together, they are responsible for the set of protocols that the internet runs on. And then the UDP, User Datagram Protocol, that uses the connectionless communication model to deliver data over an IP network. So I mentioned how in that case it's faster because you do not need to establish a connection for you to be able to send data over, but it is also unreliable because there's no guarantee on if or when or even the order in which whatever data you sent is going to be received by the receiver of that data. So this one has lower overhead in the sense that it's simpler to configure and it's simpler to use, and it's also faster. But as I said, there's no guarantee on the delivery of whatever data you are sending over that protocol. So the TCP IP connection protocol is, it's what supports the interconnection of networks that the internet uses. And it's the preferred way for transferring important files because you know that it's definitely going to be received. So because the connection has been established, you know that, okay, so for example, with the WhatsApp call, for instance, so you know that whatever you're going to say, the listener is going to hear it. So the message is going to be received. So to establish the connection, a TCP handshake happens where you synchronize. So the message is synchronized, and then there's a middle ground where it's synchronized and acknowledged. And then the third message is acknowledged. So this is about the message that is transmitted to the sender. And then we mentioned about how a connection must be established. So the sender too is also able to send back some indication that, okay, the sender is in sync with whatever is going on. So the connection has been established, and then that's way whatever data that needs to be transferred to and from the 2 points, so host A and host B, goes on. And then the UDP uses the connectionless communication. So because it's very fast, it's used for streaming services, for instance. So if, for example, you are trying to watch a movie, you're trying to stream a movie or stream a song or something, you do not constantly need to be sending back traffic. You do not need to be given that response to show that you are in sync with what's going on. Just the fact that the content is able to be served to you it's enough for you, or it's okay for you. So just that the server is able to serve whatever content to you, that is enough for you. So in that example, it would be better to use a UDP connectionless better to use the UDP protocol because that's connectionless communication, and it's faster. You'll be able to get whatever content you're looking for or whatever function you need from the server. You'll be able to get that faster. So because UDP doesn't guarantee the order or even the delivery of whatever is being transmitted, there could be instances where the various aspects of the data you're getting are not in sync, or some are being served and some are not being served at all. So that could be a UDP issue when you experience something like that when streaming. Transmission Control Protocol, the TCP handshake. There are 3 messages between the sender and then the receiver. So the packets are the packages in which the information that the network needs to be able to transmit the data, it is stored in packets. So the IP address, the destination IP address, for instance, you could find that in a packet. So if you're sending some data over the network, or you're trying to retrieve some data and you're encountering issues, when troubleshooting, you could take a look at where your packets are getting lost in communication. So it helps for you to be able to know where the issue is coming from. We've said all of this already. So join the handshake. Yeah. So when it comes to TCP, with establishing the connection for whatever communication or whatever data transfer to happen between the 2 hosts, there's also a process where it closes whatever communication at the end of the data transmission process. So with the handshake, the 3 messages are synchronize / acknowledge, and then acknowledge. And with the goodbye or with the closing of the communication, the 3 messages are finish or acknowledge, and acknowledge. So because TCP relies heavily on a connection being established. So if there's an issue or anything goes wrong and the reset flag is going to go off, and that's what shows that the connection was lost or the connection was closed abruptly and an error occurred. UDP, I mentioned that it requires less effort. So when we see lower overheads, it just means that for the configurations, it will take you less, so lower overhead, so it will take you less time or less configuration effort. Okay, so it has lower overhead and it is faster than TCP, and it also does not need to establish a connection for your data to be able to be transmitted. We've mentioned about how it's good for streaming services. And we've mentioned how if you have important messages to send or important data to be transmitted, you would rather go for TCP over UDP. Okay, 2 questions. I would call let's be quiet then. Okay, Musa. Hello, Musa. Hassanatu.
The wide area network.
Okay. So which area? Yeah, please be speaking. Okay. So I wanted to know which area network connects devices over large geographical areas.
The WAN.
Yes, the wide area network. Okay, Terry, which type of protocol ensures that a connection is established?
Hello, can you hear me?
Yes, we can hear you. It's gone again. Terry, now I can't hear you.
Can you hear me now?
Yes, I can.
You know the TCP IP.
Yeah, TCP. Thank you. And what is an example of one? So the protocol that ensures that a connection is established is the connection-oriented protocol, and then the opposite will be the connectionless protocol. So an example of the connection-oriented protocol is the TCP, and then an example of the connectionless protocol would be, who can mention? Go ahead, Dennis.
UDP.
Okay, thank you. So that's it for today. Local area networks, they connect a smaller geographic area, while the wide area networks connect a bigger geographical area. And a group of local area networks could make up a wide area network. And the network management model just helps know how data is managed and how applications are hosted. The network topology shows the way the nodes have been placed inside the network, because based on that, that's what determines how data will be transmitted between them. And the AWS VPC are virtual private cloud. It affords us the ability to be able to provision resources inside a cloud that is, let me say, dedicated for us. So we are the only people who are able to provision resources inside that network, though that network is inside AWS's cloud, or though it is within AWS's network, it is a private cloud. And then the network protocol will define the rules. It defines the rules for formatting and transmitting data between the devices on the network. So that's it for today. I hope you all remember that today is the last day for completing our labs and cases for both Cloud Foundations and Linux. Those of us, I know the cases don't take a lot of time, but then those of us who are struggling to complete the labs, you can reach out to Penty. He mentioned the last time that he has a way of he has, was it videos, but then he has a way of helping us complete our labs faster. So you could reach out to Penty about that, because today is the last day. And even those who didn't, so then those who joined the class, Yakubu, Kuru, those who joined the class late, you guys are still going to have to meet this deadline today. So what I can say is for the assignment 005 that I put in Slack, you could ignore that for now and then focus on the labs and then the cases, because today is the last day. So if you're able to get those out of the way, then tomorrow you can now focus on the assignment 5. And remember that we've done 2 topics today from networking. So those cases and labs too are also waiting for you. And I also have another announcement. Those of us who feel like we would not be able to meet those deadlines, it's actually not too late to let me know so that we can replace you guys, because this is just week 2, right? This is like week 2, and the cases and labs and then the studying and then the assignments is already a lot. And I'm going to be honest with you guys and let you know that it actually does not get I wouldn't say it does not get easier, but then the load does not get smaller. Okay. I don't know if you've gone through your Canvas content, but then in subsequent weeks, there are more labs and more cases. But I feel like once you get a hang of it, you guys are going to be able to carry the load better. So you're going to be able to handle these responsibilities that you have better. But honestly, it does not get, they don't get less than this. So if with week 1 and week 2, you're already struggling and then you feel like you won't be able to continue with us, you can just like me and then we would replace you. Please, is that okay, Yakubu?
Yes, hello. Please, can you explain more on the replace? What does that mean?
That means that you would be out of the program and then people who are waiting to get into the program would take your place. So Yakubu, have you been joining Noble's classes?
Who?
Noble. So we're having a catch up for the new students that we added. You don't know anything about that?
No.
Okay. I'll Slack you the details about it.
Okay, all right, thank you.
Yeah, so because
Yeah.
we are constantly replacing so people got into the program not really well, some of us underestimated the program, so getting in and then realize that okay, it's actually more demanding than they thought. So because we are still replacing people, so there's a session for the new people who are joining. So I will Slack the 3 of you, Yakubu, Kuru, and Nana Chimantomfe. I'll Slack you put the details to that.
Okay, all right. So one more question. Today the deadline, that means at midnight, right?
Yes, at midnight.
Okay, thank you. All right.
You're welcome. So Penti, please, Yakubu, Kuru, and Domfe don't need like special attention. Gifty.
No problem, Akuja.
Thank you, Penti.
One thing, what you meant by last me so we replace you, but you get it.
Yeah, my FM go.
I'm just going to be honest with you guys because the load is a lot, and especially when they pile up, it's just going to be so much. So that's why I encourage us to do them as and when we choose the topic. So right after we choose the topic, then you go and clear that Casey and then that's lab from there. That way you would always like be on top of things, because when you go through the canvas, you realize that the cases and labs, they just keep coming and coming. So that's really going to be your life for the next 3 months. Terry.
Yes, my challenge is basically to the data. We didn't get them. We've not had them yet. Maybe they have a specific time to give them.
Yeah, it
That
comes
would be
after the
fine.
first month.
Okay, and the stipend as well, right?
Yes.
Okay, because my budget on yeah.
Pardon?
I've run a budget against it. That's why.
Oh, it will come at the end of the month. It will come. So
That's
after,
all.
so we had our first class. When was the first class? It was
This is our
ending
second
of
week.
May.
Yes.
And so I think 27th May.
28th.
It was
28th
28th
of
May.
yeah.
So 28th June, your first stipend and data bundle should come.
Thank you.
You're welcome. Ruben.
Hello, madam. I just want to encourage all of us because you have rightly said it's not something that's it's easy because every day at least you have to tackle about three: the lab, the chaos, the cases, the you have to also study, you have to learn in order to do all these things. So I will encourage each and everyone to take it serious. And I know that if we take it serious, at the end of the day, we will just come out with flying colors. Madam is also doing best. We also encourage you to handle us the way we are. Yeah, we do appreciate your efforts. So we thank you very much.
All
I
right,
just want to
Ruben. Thank you for
thank
that.
you.
Yes, Emmanuel.
I think anyone a fence Ruben
Ruben
Akam.
Akano.
But
because
my
I feel like we've done week 1. Into week 1, we're supposed to submit that. We're able to submit the assignment week 2. So I know a lot of us have done cloud foundations. Into Ababeju Hanu, I really don't expect say people would be dropping off because you made it this far. So like Mia, you're in and then finish with it. You get it. So I really don't expect people to drop off, but I just feel like we should also have that in mind that the program is actually demanding because we need to give you the like a wholesome training. So all these cases and all these labs, they are part of the whole training. So for you to get the maximum benefits, you need to be doing those things. And see, I don't even I don't even
Oh, yeah.
encourage that anybody drop out or anything, but obiane na hoarding.
Sure. And quickly. Quickly, I think I wanted some clarity on the labs. For week 2, are you expecting to complete everything?